Let's work through and prove this identity. So we have cosine of 4t minus cosine of 2t, a difference going on in this numerator, all over sine of 4t plus sine of 2t, a sum in this denominator. And eventually we want to show that this is equal to negative tangent of t. So this looks kind of complicated from the beginning, but what I do notice is we have some sums or differences over on the left-hand side. What I've listed out over here on the right is all of our sum to product or difference to product formulas. So I'm going to begin with the left-hand side and kind of focus on the numerator and denominator individually. So the numerator, we have a difference of cosine minus cosine. So what that's pointing me towards is I'm going to use this formula, the third one down, and fill into that for our numerator. So I'm going to identify that 4t is our alpha and the 2t is our beta, and then fill in to the right half. So I can say at least that numerator is going to equal negative 2 times sine of, we say, alpha plus beta. So in our case, that's 4t plus 2t all over 2. And that's going to be multiplied by sine of alpha minus beta over 2. So sine of alpha, we said, was 4t minus beta 2t all over 2. So that takes care of our numerator for the time being. Our denominator, I notice we have sine plus sine. That's pointing me towards this sum to product formula for sine, the top one over here. So in filling in there, I'm going to say 4t's again our alpha, 2t happens to be the same here is going to be our beta, and we're going to fill in here. So that's going to be 2 times sine of alpha plus beta, so 4t plus 2t all over 2, multiplied by cosine of alpha minus beta, so 4t minus 2t all over 2. And we filled into the sum to product formula here for sine plus sine. Next, let's just take our time and reduce this down, simplify wherever possible. So I may not be doing this the very fastest way. You may have quicker ways to get through this, but I'm going to start out and say, well, inside of this sine function, we have 4t's plus 2t's, makes 6t's, still over 2, multiplied by sine of 4t minus 2t's in this numerator makes 2t's, still over 2, divided by, bringing that 2 along from our denominator, the sine, and a very similar reducing down here, 4t plus 2 more t's makes 6t's, over 2 in that sine function, and then we still have this cosine function to reduce down what's on the inside. So we can say 4t minus 2t's, again, is 2t's, divided by 2. A little bit more reducing down before we cancel things out. I'm going to bring along that negative 2. I can say this is sine of 3t, 6t over 2, times sine of t, divided by 2 times sine of 3t, times cosine of t, just reducing down these fractions. All right, at this point, hopefully we kind of notice like we can do a little bit more reducing down. We have a 2 in the numerator and a 2 in the denominator. That makes a 1. We have a sine of 3t over a sine of 3t. Again, that'll make a 1. So what are we left with after those all make 1s and we get rid of common factors? Well, we still have a negative that came from the out in front. Now we have sine of t over cosine of t. That didn't go away. And hopefully we've got down our quotient identities. This sine of t over cosine of t is equivalent to tangent of t, which is what we were looking to get to over on the right-hand side. Again, this is the quotient identity, helping us go from sine over cosine to tangent. And that's what we wanted to prove. We wanted to show this is everything on the left-hand side is equal to what's on the right-hand side. So I hope this made sense as we walk through, used our formulas for product, or sum to product, I should say. Identify alpha and beta as you go through and make it a plug-in problem, then reduce down using some algebra. Good luck.